What happens when you have an individual that shows the dominant phenotype but you don't know its genotype? Because of the law of dominance, you don't know if a person with brown eyes has a big B genotype or a big B little b genotype because the brown allele masks the blue allele. Or in pea plants, you don't know if a yellow pea has a big Y genotype or a big Y little y genotype, again because the yellow allele masks the green. So this is when a backcross or a test cross comes in handy. In a backcross, the individual with an unknown genotype is crossed with a homozygous recessive individual. So for these two examples, you'd have a unknown brown-eyed person crossed with a blue-eyed person, which isn't as realistic, or a unknown yellow pea individual crossed with a green pea individual. So here's another example that's more detailed using dog fur. So a dog breeder wants to know whether his black dog has homozygous black fur, big B, or heterozygous black fur, big B, little b. And so he crosses it with a homozygous brown fur dog. So this is same deal as here. It's big B blank, uncertain, times little b, and this is your brown dog with the homozygous recessive genotype. So the reason why this works is if the dog is heterozygous, there's a 50% chance that the offspring will have either black or brown fur. And if the dog is homozygous, all the offspring will have black fur. So based on the offspring, the dog breeder can work backwards to tell whether his black dog is homozygous dominant or heterozygous. And you can simplify this above Punnett square to only have one row, as we've been doing in our monohybrid and dihybrid crosses, because they're like the same thing, and there's actually only one gamete combination for the brown dog individual. Interestingly, if all offspring have black fur, it is not guaranteed that the dog is homozygous. You may just happen to have all black furred offspring despite having a heterozygous parent. It could just be attributable to chance. But it's a pretty educated guess, and the more offspring the dog produces that are black, the stronger your conclusion, the less it's able to be attributed to chance. But if you have even just one brown dog, even out of like 100 offspring, you somehow only have one brown dog, you know that this dog is heterozygous because clearly there's genetic information in the black dog to produce brown offspring. And that is a backcross or a test cross.